Dear students, welcome. Probably this is our 9th class on reduction formula. Let us start. First, we will try to solve these two problems. I have already written in the board. The first question is this: if ion equal to integration x to the power n a minus x whole to the power half dx, then we have to prove this one. Hence, evaluate this. This means that using this formula we have to evaluate this integral. We have to evaluate this integral. First of all, we shall try to find this reduction formula. This is a reduction formula. It is ion. It is n minus 1. The reduction formula is. Now ion equal to, you see, ion equal to solution. The solution of the question number 1. Ion, this is equal to integration x to the power n a minus x whole to the power half dx. Whole to the power half dx. You see, generally we take the second function in case of the integration. When we are to integrate this by parts, we take the second function if each integral is known. You see, a minus x whole to the power half. What is the integral of this a minus x whole to the power half? It is of the form x to the power half. What is the integral of x to the power half? X to the power 3 by 2 by 3 by 2. If you differentiate a minus x, then you will get minus 1. If you put a minus x equal to z, dx will be equal to minus dz. Therefore, this integral will be equal to minus z to the power 3 by 2 divided by 3 by 2 with a minus sign. Therefore, this integral will be a minus x whole to the power 3 by 2 by 3 by 2 with a minus sign. This is equal to x to the power n a minus x whole to the power 3 by 2 divided by 3 by 2 with a minus sign. With a minus sign, this. First function, this integration of the second function, minus integral the differentiation of the first function into integration of the second function will be divided by 3 by 2 dx. Integrating by parts, taking a minus x whole to the power half as the second function. You may write here integrating by parts. Integrating by parts. Taking a minus x whole to the power half as the second function. Integrating by parts, taking a minus x whole to the power half as the second function. This is equal to minus 2 by 3 x to the power m a minus x whole to the power 3 by 2. Minus, this will be plus, and it will be twice m by 3 integral x to the power m minus 1 a minus x whole to the power 3 by 2. A minus x whole to the power. In the main integration, it is a minus x whole to the power half. A minus x whole to the power 3 by 2. This can be written as a minus x into a minus x whole to the power 1 by 2. Write here a minus x into a minus x whole to the power 1 by 2. This will give you a minus x whole to the power 3 by 2. A minus x whole to the power, in place of a minus x whole to the power 3 by 2, we have written it as a minus x into a minus x whole to the power half, which is equal to minus 2 by 3 x to the power m a minus x whole to the power 3 by 2 plus, you see, this can be written in the addition of two terms. X to the power n minus 1 a minus x whole to the power half into a, this is one term, minus the second term will be x to the power n minus 1 into x a minus x whole to the power half. just write like this. Twice n by 3 integration a into integration x to the power n minus 1 a minus x whole to the power half dx minus integral x to the power n minus 1 this plus 1 into a minus x whole to the power half dx. You may write like this. This is equal to minus 2 by 3 x to the power n a minus x whole to the power 3 by 2 plus twice n a by 3 integral x to the power n minus 1 into a minus x whole to the power 1 by 2 dx plus minus, again this will be minus, twice n by 3 integral x to the power n a minus x whole to the power half dx. Can I write like this? Twice n by 3, yes, we have done no mistake. This is the question. Now, now you see, this means iron equal to minus 2 by 3 x to the power n a minus x whole to the power 3 by 2 plus twice n a by 3. You see, iron stands for x to the power n a minus x whole to the power half. This is x to the power n minus 1 a minus x whole to the power half. What is the difference between this term and this term? Just n is replaced by n minus 1. If in stands for this, this must stand for in minus 1. In minus 1 minus twice n by 3. This is again in, this is again in. This means take this to the left hand side, twice n by 3 in. This is equal to twice n a by 3 in minus 1 minus 2 by 3 x to the power n a minus x whole to the power 3 by 2. You may write like this. Now multiply by 3, 3 will be cancelled, and divided by twice n plus 3, or multiply it by 3. You may write in. This is equal to twice n a in minus 1 minus 2 times of x to the power n a minus x whole to the power 3 by 2. Proved. Very simple. Proved. We have to prove this one. We have proved this. Now we shall apply this to find the integral 0 to a x square a minus x ax minus x square whole to the dx. Now we shall apply this reduction formula. Now we shall apply this reduction formula to find the integral of this. If second part, we are going to answer the second part. Second part, if in equal to 0 to a x to the power n a minus x whole to the power half dx. In the limit, we have taken the limit 0 to a. Then suppose it is number 1. Then from 1 we get. What we will get? You will get in equal to twice n a by n plus 3in minus 1 minus twice x to the power m a minus x whole to the power 3 by 2 divided by twice m plus 3 0 to a. 0 to a. Here in minus 1 equal to, here in minus 1. In minus 1 will be equal to 0 to a, x to the power n minus 1, a minus x whole to the power half dx. Right? Just we have taken the limit 0 to a. If in equal to 0 to a, x to the power n a minus x whole to the power half, then in minus 1 will be 0 to a, x to the power n minus 1 a minus x whole to the power half. And here we have to. Now you see the second this second term. If you put x is equal to a, it will be a minus a. It will be a minus a. 0. If you put 0, then there is an x to the power n, 0 to the power n, 0. If you put x is equal to 0, it will be 0. If you put x is equal to a, this term will be equal to 0. Consequently, no contribution, there will be no contribution from this term. Therefore, this means you will get in equal to twice na by twice m plus 3 in minus 1 minus 0 minus 0. This means in equal to twice na by twice n plus 3 in minus 1. You will get this one. Now, our aim is to find the integration of this 0 to a x square ax minus x square whole to the power ax minus x square dx. Now, integration 0 to a x square root over ax minus x square dx. We have to find this integral. This is equal to integration 0 to a x square x to the power half a minus x root over dx. You may write like this. This is equal to integration 0 to a x to the power 5 by 2 a minus x whole to the power half dx. Compare this with this. Suppose this is star. Comparing this with star, then this is star. Okay, I want to say that in equal to this one, x to the power n a minus x whole to the power half. It will be definitely I5 by 2. In place of n, 5 by 2 is there. Means x to the power, in place of x to the power n, in this integral, it is x to the power 5 by 2. It will be I5 by 2. This will be equal to I5 by 2. This is equal to I5 by 2. Now apply star, I5 by 2. For n, you put 5 by 2. 2 times of 5 by 2. A. 2 times of 5 by 2 plus 3 I 5 by 2 minus 1. 5 by 2 minus 1. You may write here applying star. We have applied this one. This is equal to 5a divided by 5 plus 3 8 I 3 by 2. I3 by 2. Now, this is equal to 5a by 8 I3 by 2. Again apply star. 2 times of 3 by 2 2 times of 3 by 2, this term is 2 times of 3 by 2 into a divided by 2 times of 3 by 2 plus 3 I 3 by 2 minus 1 I 3 by 2 minus 1. That is, we have got this is equal to 5a by, I am writing once again, we have got 5a by 8. 5a by 8 into 2 cancel, thrice a divided by 6. I am writing this term once again. 3 by 2a, 2 times of 3 by 2 plus 3. Because of the camera, I have written this one. I have written once again this one. This term, I am not removing this. Now, this is equal to 5a by 8. This will be equal to thrice a by 6 into I 1 by 2. I 1 by 2. 3 here 2. This is equal to 5 a square divided by 16 I half. Now you cannot apply this one. Yeah. Now you see, what is I half? This is equal to 5 a square by 16 integration 0 to a. In place of n, you will have to put half, x to the power half. X to the power half. And a minus x whole to the power 1 by 2. In place of n, just put x to the power half. This can be integrated very easily. Now it is required integral. This is the required integral. Now to integrate this, put x equal to a sin square theta. This means dx equal to a twice sin theta cos theta into d theta. X equal to 0. This implies theta is equal to 0. X equal to a. This means theta is equal to pi by 2. X is equal to a. This means theta is equal to pi by 2. Therefore, this one is, what is this one? Therefore, this one. Therefore, integration 0 to a, main integral, we are integrating this one, a minus x square dx. This is equal to this 5 a square divided by 16. Integration this time theta equal to 0 to pi by 2. X to the power half. A sin square theta whole to the power half. A minus a sin square theta whole to the power half. Dx means twice a sin theta cos theta. Sin theta cos theta. This one. Now this is equal to 5 a square divided by 16. 5 a square by 16. A to the power half will be, can be taken outside the sign of integration. This a to the power half, it can also be taken outside the sign of integration into twice a. Integration 0 to pi by 2. 0 to pi by 2. What is this? Sin theta. What is this? 1 minus sin square theta equal to cos square theta whole to the power half, means cos theta into sin theta cos theta d theta. Sin theta cos theta. This is equal to 5 a square divided by 16. You may write here 8. 5 a square divided by 8. a to the power, this is a into a, again a square. Integration 0 to pi by 2. Sin square theta, cos square theta, d theta. You will get this. This is equal to 5a to the power 4 divided by 8. You may write here 2 minus 1 divided by 2 plus 2. Integration 0 to pi by 2. Sin square theta into cos theta whole to the power 0 d theta. Since this is equal to 0 to pi by 2, I told you earlier, sin to the power mx cos to the power nx dx. Then I am equal to n minus 1 by m plus n. I am m minus 2. This formula has been applied here. You see, n is equal to 2. 2 minus 1 divided by 2 plus 2. 0 to pi by 2. It is as it is. I am m minus 2 cos theta whole square whole to the power cos theta whole to the power 2 minus 2 cos theta whole to the power 0. You may write like this also, m minus 1 by m plus n. I m minus 2n. You can apply that formula also. M minus 1 divided by m plus n. I m minus 2m. The same result will come. This is equal to 5a square, 5a to the power 4 divided by 8. 1 by 4. It is 1 sin square theta, again 1 by 2 into pi by 2. This is equal to 5 pi a to the power 4. 5 pi a to the power 4. 5 pi a to the power 4 divided by 128. 5 pi a to the power 4 divided by 128. This is the answer. 5 pi a to the power 4 divided by 128. This means we have done question number 1. First of all, we prove this reduction formula. Then we apply this to find the integral dish. Just let me do this. Just we have, since we have applied this. I am giving you to write down, giving you a chance to write down. Just perhaps you have written everything. Perhaps you have noted it. Now I am going to solve the number 2, question number 2. Let me remove. Question number 2. In question number 2 also, there are 2 parts. One part is this and the other part is this. Same question. Same type of question. One part is this, we have to find the reduction formula this, then we will apply this to evaluate this one. This one. Now, here you see un equal to solution of 2. Un equal to integration x to the power m x square minus x square whole to the power half dx. To find the reduction formula, we are going to apply the method of integration by parts. What will be the second part for this integral? What will be the second part of this integral? You see, this can be written as minus integral x to the power m minus 1 x square minus x square whole to the power half into minus x dx. Can I write like this? This minus cancel, will be plus. X to the power n minus 1 into x will be x to the power n. This means this can be written as like this. This can be written as like this. Now we can easily find the integration of this. Un equal to this, un equal to this. Suppose this is number 1. Put a square minus x square equal to z square. Suppose put a square minus x square, this is equal to z square. This means minus twice x dx equal to twice z dz. This means minus x dx equal to z dz. You may write like this. Therefore, integration a square minus x square whole to the power half minus x dx. This can be written as this whole to the power half means z. Z into z dz. Z into z dz. This is equal to z square. Integration z square dz. This is equal to z cube by 3. Equal to 1 by 3. 1 by 3. What is z? A square minus x square. A square minus x square whole to the power half. Z is whole to the power half. Z cube means whole to the power 3 by 2. The integration will be this. The integration of this term from this and this. Integration from this and this will be equal to this. Now integrate this by 1 by parts. Regarding a square minus x square whole to the power half minus x as the second function. Now integrating by parts. Regarding or taking a square minus x square whole to the power half into minus x as the second function. We get. Now integrating by parts, taking a square minus x square whole to the power half into minus x as the second function, we get. Integrating 1 by parts. You may write here integrating this one by parts. You will get. I am going to integrate 1 by parts regarding this a square minus x square whole to the power half minus x as the second function. Un equal to, you will get un equal to minus sign is also there, is already there, minus. First function x to the power n minus 1. The integration of the second function 1 by 3. Yes, 1 by 3. A square minus x square whole to the power 3 by 2. Minus integration, the differentiation of the first function into the integration of the second function. Integration of the second function, the integral of this. Just put the bracket sign here. Right? We have integrated this by parts, taking this x square minus x square whole to the power half into minus x as the second function. This is equal to minus 1 by 3 x to the power m minus 1 a square minus x square whole to the power 3 by 2 minus plus n minus 1 divided by 3 integral x to the power n minus 2. This can be written as a square minus x square whole to the power half dx. Right? A square minus x square whole to the power 3 by 2. I have written this term as a square minus x square into root over a square minus x square. This is equal to, from this term you may write, this is equal to minus 1 by 3 x to the power n minus 1 a square minus x square whole to the power 3 by 2 plus n minus 1 divided by 3. Now, we can write this term as the sum of two terms. How? X to the power n minus 2 into a square minus x square whole to the power half into x square. This is one term. The second term is x to the power n minus 2 into x square minus x square whole to the power half. This is the second term. Thus, this term will be written as the sum of two terms. A square into integral x to the power n minus 2 a square minus x square whole to the power half dx plus minus we have taken already n minus 1 divided by 3 common integral x to the power n minus 2 into this x square plus 2 a square minus x square whole to the power half dx. Can I write like this? Just note it. This is equal to minus 1 by 3 x to the power n minus 1 a square minus x square whole to the power 3 by 2 plus n minus 1 a square divided by 3. You see, un equal to this. What is this term? It is nothing but un minus 2. A square minus x square whole to the power half. This term is already here. In place of n, it is n minus 2. If it is diluted by un, it will be diluted by un minus 2. un minus 2. This plus 2 minus 2 cancel. Minus n minus 1 by 3. What is this? Integration x to the power n a square minus x square whole to the power half. Integration x to the power n a square minus x square whole to the power half. What is this? This is un. You may write here un. Left hand side was un. This means take the term un to the left hand side. 1 plus n minus 1 divided by 3 un. This is equal to minus 1 by 3 x to the power n minus 1 a square minus x square whole to the power 3 by 2 plus n minus 1 a square divided by 3 un minus 2. Note it. I am giving you a chance to know. Now, this much. This means multiply both sides by 3. It will be 3 plus n minus 1 un. It will be minus x to the power n minus 1 a square minus x square whole to the power 3 by 2 plus n minus 1 into a square un minus 2. This means un equal to what will be this? N plus 2 divided by n plus 2 minus x to the power n minus 1 a square minus x square whole to the power 3 by 2 divided by n plus 2. It is n plus 2. It is nothing but n plus 2. 3 minus 1 is equal to 2. N plus 2. Plus n minus 1 by n plus 2. N minus 1 by n plus 2. A square un minus 2. You may write here proved. Just note it. We have proved this one. Un equal to minus x to the power n minus 1 a square minus x square whole to the power 3 by 2 by n plus 2. Thus, the first part has been proved. Now, I am going to find the second part. Just as the previous previous question. Just take the limit from 0 to a. 0 to even for the indefinite integral we have established this. If un equal to 0 to a, then what will happen? Let's see. Let us suppose that. Let us suppose that. Let us suppose that un equal to integration 0 to a x to the power n x square minus x square whole to the power half dx. Let us suppose this one. Not notate, perhaps not notate. Then suppose this this number is suppose a. This number is a. Then from a we get then un minus 2 will be equal to definitely 0 to a u to the power n minus 2 you know a square minus x square whole to the power half dx. It will be this. Then from a we get un equal to minus x to the power n minus 1 a square minus x square whole to the power 3 by 2 divided by n plus 2. It will be equal to 0 to a plus n minus 1 divided by n plus 2 a square un minus 2 In place of this, just I have added the limit of the integration from 0 to a. If you take the limit, definite integral limit from 0 to a, then we will get this one. Suppose now you see this term. If you put x equal to a here, a square minus a square, this will be equal to 0. If you put a, this term will vanish. If you put 0, then put x is equal to 0 here. This term again vanish. Therefore, you will not get any contribution from this term. This term will vanish totally. Therefore, or this means un equal to 0 minus 0. You will get 0 minus 0 plus n minus 1 divided by n plus 2 a square un minus 2. You will get this one. This means finally you will get n minus 1 divided by n plus 2 a square into un minus 2 if you take the definite integral from 0 to a. The result, this reduction formula will become this one. There will be no this term. You will get simply n minus 1 by n plus 2 a square this. If you take the limit from 0 to a. Now, now I am going to find this integral. Now, second part. This denoted this equation I am denoting it by star. Second part. For second part, 0 to a x to the power 4 root of r x square minus x square dx. What is this? 0 to a x to the power 4 root of r x square minus x square dx. It is, compare this with this, you will get it is equal to u4. This is nothing but u4. This is equal to u4. I am writing just below this one. This is equal to 4 minus 1 divided by 4 plus 2. A square into u 4 minus 2. You may write here applying star. Applying star. Applying star, you will get this one. This is equal to 3 divided by 6 a square u2. This is equal to 1 by 2 a square u2. 1 by 2 a square into u2. You will get this one. Now, if I again apply the star, then you will get u0. u0 means x to the power 0. This is equal to, from this, is equal to 1 by 2 a square. Again apply this star. 2 minus 1. Because this time n equal to 2 into a square. u2 minus 2, you will get this. This is equal to, you will get 1 by 4, 1 by 8. A to the power 4 divided by 8. 1 by 8, a to the power 4, u0. 1 by 8, a to the power 4, u0. A to the power 4, u0. You will get this one. Now, this is equal to 1 by 8 a to the power 4 u0. What is u0? Integration 0 to a. X to the power 0. X to the power n. If it is un, then we will write x to the power n into this. This term is common. If we put x to the power 0, u0, you will have to write x to the power 0 into a square minus x square whole to the power half dx. You will get this one. This is equal to 1 by 8 a to the power 4 integration 0 to a. It is nothing but a square minus x square dx. The standard integral. This is equal to 1 by 8 a to the power 4 x root over a square minus x square divided by 2 plus a square by 2 sin inverse x by a. 0 to a, the integration of this is this, 0 to a. This is equal to 1 by 8 a to the power 4. Put, x is equal to a. This term will be equal to 0. If you put x is equal to 0 here, no contribution from this term. 0 minus 0 plus. A square by 2. It is sin inverse 1 minus sin inverse 0. You will get sin inverse 1 minus sin inverse 0. This is equal to a to the power 6 divided by 16. Sin inverse 1 means pi by 2 minus 0. The answer will be equal to pi a to the power 6 divided by 32. Answer should be this. Answer of this question should be equal to this. Pi a to the power 6 divided by the 32. Dear students, we have solved these two problems. Let us take another very interesting problem. Now, I am going to solve this problem. Prove the reduction formula. I am equal to integration x to the power m and root over twice ax minus x square equal to this. This is first part we have to prove. The second part is also there. If I am equal to 0 to twice a, the integration 0 to twice a is, then we have to prove this one. I am equal to this one. I am will be equal to a to the power m plus 2 twice m plus 1 factorial pi divided by 2 to the power m factorial m plus 2. And using this result, we have to evaluate this one. 0 to twice a x cube, this one. We have to we will evaluate this one using this result. and or otherwise also we will try to solve otherwise, the alternative method. Now you see, I am going to prove the first part. I am equal to, solution will be like this, I am equal to integration x to the power m root over twice ax minus x square dx. X square dx. I am equal to this. This is equal to integration x to the power m. X is common, which is under root. Means x to the power half. You will get twice a minus x dx. You will get this one. You will get this. This is equal to integration x to the power m plus half twice a minus x whole to the power half dx. I am equal to this. You see, I am in place of this, instead of this, I am may denote this one also. This can be written as like this also. X to the power m plus half twice a minus x, because you see, twice a minus x whole to the power half can be integrated very easily. It can be integrated very easily, because the integration of this is minus twice a minus x whole to the power 3 by 2 divided by 3 by 2. Therefore, you can integrate this by parts. You can integrate this by parts. Suppose number 1, this is number 1. Integrating 1 by parts, taking twice a minus x whole to the power half as the second function. Integrating 1 by parts, taking twice a minus x whole to the power half as the second function. Second function we get. I am equal to, first function is x to the power m plus half. The integration of the second function minus twice a minus x whole to the power 3 by 2 divided by 3 by 2. You will get this one. Am I right? First function, integration of the second function, minus integration, differentiation of the first function, m plus half, x to the power m minus half, m plus half minus 1, it will be m minus half, into the integration of this, you will get minus twice a minus x, whole to the power 3 by 2 divided by 3 by 2. Right? Integrate this by parts. Taking twice a minus x whole to the power half as the second function, you will get this one. You will get this one. Now, I am equal to this. I am equal to this. Just remember this time. Remember this. I am stands for x to the power m plus half. Twice a minus x whole to the power half. This is I am. This means I am equal to, you may write here minus 2 by 3 x to the power m plus half into twice a minus x whole to the power 3 by 2, you may write like this. Minus minus, it will be plus. 2 by 3 m plus half, 2 by 3 m plus half, integrate, you know, x to the power m minus half into twice a minus x whole to the power 3 by 2. You may write like this. Note down. Note it. perhaps we have not done any mistake up to this step. 2 by 3, let me check. 2 by 3 m plus half there. Right. This means I am equal to minus 2 by 3 x to the power m plus half twice a minus x whole to the power 3 by 2 plus 2 by 3 m plus half. This I am writing, I should write, yeah, this. Just I am writing, I am equal to integration x to the power m plus half twice a minus x whole to the power half dx. This one. Let me remove this. This plus 2 by 3 m plus half 2 by 3 m plus half into integral x to the power m minus half twice a minus x twice a minus x whole to the power half dx. Can I write like this? Now, as the previous two problems, this term can be written as the sum of two terms. The common term will be x to the power m minus half twice a minus x whole to the power half. This implies I am equal to minus 2 by 3 x to the power m plus half twice a minus x whole to the power 3 by 2 plus 2 by 3 m plus half this twice you write this twice integral x to the power m minus half twice a minus x whole to the power half dx. The first term has been written. Now, what will be the second term? Plus minus, it will be minus 2 by 3 m plus half 2 by 3 m plus half integral x to the power m minus half into x means plus 1 into x to the power 1 x to the power 1 means m minus half plus 1 into twice a minus x whole to the power half dx. Right? This means I am equal to, you may write here minus 2 by 3 x to the power m plus half twice a minus x whole to the power 3 by 2 plus these two will be cancelled. These two twice and plus 1 plus 2 by 3, right, 2 by 3 twice m plus 1 divided by 2 into twice a divided by 2 into twice a. This integral can be written as x to the power, what is I am? X to the power m plus half. You may write here minus 1 m plus half minus 1. For m minus half you write x to the power m plus half minus 1 into twice a minus x whole to the power half dx. Now what about this term? This equal to minus 2 by 3 into twice m plus 1 divided by 2 integral x to the power m plus half twice a minus x whole to the power half dx. Thus write down. Thus write down. Now you see What is I am? I am equal to integral x to the power m plus half into twice a minus x whole to the power half dx. I am stands for integration x to the power m plus half into root over twice a minus x into root over twice a minus x. You see here. First write this term. Perhaps I have written up to this. Now, let me. I am equal to. This is minus 2 by 3. X to the power m plus half. No change of this term. Whole to the power 3 by 2. Here you see, this 2 will be cancelled. Twice a by 3 plus twice a by 3 into twice m plus 1. Twice a by 3 into twice m plus 1. What is this? Integration x to the power m plus half minus 1. I am stands for integration x to the power m plus half into root over twice a minus x. This can be replaced by, you see, x to the power m plus half and twice a minus x whole to the power half. It is common. It is there. In place of x to the power m plus half, it is x to the power m plus half minus 1. Therefore, this can be denoted by what? This can be denoted by I m minus 1. I m minus 1. This term remains unchanged. It is common. X to the power. If it is m plus half, then we write it as I am. It is this minus 1. You may write I am minus 1. You may write it here m minus 1. Now these two will be cancelled. Minus twice m plus 1 divided by 3. Twice m plus 1 divided by 3. What is this? This is I am. This is I am. This is I am. Understand? Now, take this term to the right hand side. This term to the right hand side, left hand side. You will get, this means 1 plus twice m minus 1 divided by 3 I am. This is equal to minus 2 by 3 x to the power m plus half twice a minus x whole to the power 3 by 2 plus twice a by 3 twice m plus 1 into I m minus 1. I m minus 1. Now multiply both sides by 3. If you multiply both sides by 3, then you will get twice m. 3 minus 1 means 2. You know, it is not twice m minus 1, it is twice m plus 1. Twice m plus 1. Twice m, 3 plus 1, it is 4. I am. Twice m plus 3 plus 1, twice m plus 4. I am. This is equal to minus 2 x to the power m plus half twice a minus x whole to the power 3 by 2 plus twice a twice m plus 1 I m minus 1. You may write here multiplying both sides by 3. Multiplying both sides by 3. Multiplying by 3. Multiplying by 3. Multiplying both sides by 3. This means here is a 2. 2 cancel. 2 can be cancelled. This means I am equal to 2. If 2 is common, you will get m plus 2. This 2 will be cancelled and this 2 will be cancelled. This 2 will be cancelled. I am will be equal to minus x to the power m plus half divided by m plus 2 into twice a minus x whole to the power 3 by 2 plus these 2 cancel, these 2 after these 2 cancel, then these 2 will be also cancelled, plus a twice m plus 1 divided by m plus 2 I m minus 1. In the question, just you will have to write it here A. You should write here A. Just A was dropped in writing the question. Now we have established this. I am equal to minus x to the power m plus half divided by this. Now you see. This means I am equal to minus 1 by m plus 2 x to the power m minus 1 plus 1 plus half. You may write like this: x to the power m minus 1 plus 1 plus half into twice a minus x whole to the power 3 by 2. Twice a minus x whole to the power 3 by 2. You may write like this. Plus a times of twice m plus 1 divided by m plus 2. It is as it is. I am minus 1. It is as it is. This means you may write I am equal to minus 1 by m plus 2 x to the power m minus 1 into x to the power 3 by 2. 1 plus half, this is equal to 3 by 2. 1 plus half equal to 3 by 2 into twice a minus x whole to the power 3 by 2 plus twice m plus 1 divided by m plus 2 into a I m minus 1 into a I m minus 1. This one. Now you see. This means I am equal to minus x to the power m minus 1 divided by m plus 2 twice a minus x into x whole to the power 3 by 2. Can I write like this? These two terms can be combined, can be written combinedly in this way. Plus twice m plus 1 divided by m plus 2. A I m minus 1. This means I am equal to minus x to the power m minus 1 divided by m plus 2. It is twice x minus x square whole to the power 3 by 2 plus twice m plus 1 divided by m plus 2 into a I m minus 1. You see, x to minus x to the power m minus 1 twice a minus x twice ax minus x square. I am very sure that there should have been a m plus 2 in the denominator. I am very sorry. Please correct it. The question should have been this minus. I am very sure that there is a m plus 2 in the denominator. There must be m plus 2 in the denominator because Here this denominator, in this denominator also m plus 2, it must be m plus 2. We have done no mistake in doing the problem. We have done no mistake in doing the problem. But we wrote the question wrongly. In m plus 2 should be here and a was dropped in writing the question. A was dropped and m plus 2 was dropped in writing the question. But when we were solving the problem, we have done no mistake. Please clear it. This is equal to this. Now minus x to the power m minus 1 twice x minus x square whole to the power 3 by 2 divided by m plus 2. It must be m plus 2. I am very sure. Twice m plus 1 divided by m plus 2. I am minus 1. Hence proved. The first part, this part has been proved. My dear students, this part has been proved. Don't make any confusion, please. In solving the problem, we have done no mistake. But in writing the question, we dropped first m plus 2 and this a. For that I am very sorry. And don't make any confused. The answer is this. We have done no mistake. This is the first part has been proved. First part has been proved. Hence proved. Minus x to the power m minus 1 twice a x minus x square root to the power 3 by 2 divided by m plus 2 should be there. Plus twice m plus 1 by m plus 2. A into I m minus 1. A into I m minus 1. The first part has been proved. Now I am going to solve the second part. Let me start the second part. The first part has been done. The second part. Now I am going to start the second part. Second part. I am equal to this. I am equal to integration 0 to twice a x to the power m root over twice ax minus x square dx, which is equal to 0 to twice a x to the power m plus half root over twice a minus x dx. Twice a minus x dx. Now, in the first part, put mark it as number, suppose number a. Equation number a. First part number a. I am equal to this. Then from a we get. From a we get. From a we get. Then from a we get I am equal to minus x to the power m minus 1 divided by m plus 2 twice ax minus x square whole to the power 3 by 2 this 0 to twice a plus twice m plus 1 divided by m plus 2a I m minus 1. Right? Now, if you put x is equal to 0, this term will be 0. If you put x is equal to twice a, it will be twice a into twice a, 4a square, minus twice a whole square, 4a square. 4a square minus 4a square, 0. If you put twice a, consequently, if you put x is equal to twice a, this term will be 0. If you put x is equal to 0, then also it will be also 0. Therefore, no contribution from this term. 0 minus 0. This means I am equal to twice m plus 0 minus 0. One term 0 minus 0 plus twice m plus 1 divided by m plus 2 a I m minus 1. You will get this. This means I am equal to twice m plus 1 divided by m plus 2 a I m minus 1. Am I right? When you take the limit from 0 to twice a, then you will get this. Suppose this is number 1. This is number 1. This is number 1. We are going to prove the part number 2. This is number 1. Replacing m by m minus 1 in 1 we get. Replacing m by m minus 1 in 1 we get. In 1 we get m by m minus 1 in 1 we get. I m minus 1 equal to 2 times of m minus 1 plus 1 divided by m minus 1 plus 2 ai m minus 1 minus 1, that is I m minus 1 equal to twice m minus 1 divided by m plus 1 into a I m minus 2. Suppose this is number 2. Suppose this is number 2. This is number 2. Twice m minus 1 divided by m plus 1. Applying 2 in 1 we get. Applying this 2 in 1 we get. Applying 2 in 1 we get. I am equal to twice m plus 1 divided by m plus 2 times of a into twice m minus 1 divided by m plus 1a into I m minus 1. I m minus 2. I am equal to this. For I am minus 1, twice m minus 1. What? Twice m minus 1? I have got this. Now, replacing m by m minus 2. Suppose this is number 3. This is number 3. Replacing m by m minus 2 in 1 we get. Now replace m by m minus 2 in 1. You will get I m minus 2 equal to 2 times of m minus 2 plus 1 divided by m minus 2 plus 2 into a I m minus 2 minus 1 I m minus 2 minus 1. This means this is equal to twice m minus 3 divided by m a I m minus 3 a I m minus 3. I m minus 2 is equal to this. Suppose this is number 4. Now apply 4 in 3 we get. Applying 4 in 3. 4 in 3 we get. Applying 4 in 3 we get. I am equal to. Applying 4 in 3 we get. I am equal to. You will get twice m plus 1 divided by m plus 2a twice m minus 1 divided by m plus 1a. For I m minus twice m minus 3 divided by m into a im minus 3. Im minus 3. You will get this one. You will get this one. Excuse me. You will get this one. I am equal to this. Proceeding in this way, if you proceed in this way, I am was 0 to twice a x to the power m root over twice ax minus x square dx. Proceeding in this way, ultimately you will get x to the power 0. You may get x to the power 0 here. You may get x to the power 0 here. If you get x to the power 0, then in this term we will have to put m equal to 3. M equal to 3. Now, proceeding in this way, we shall ultimately get. Proceeding in this way, we shall ultimately get proceeding in this way, we shall ultimately get you see, I am equal to, you will ultimately get I am, this is equal to twice m plus 1 divided by m plus 2 times of a twice m minus 1 divided by m plus 1 a twice m minus 3 divided by m a. In this way, ultimately the last term will be m minus 3, next term will be m minus 4, next term will be m minus 5, 1 will be reduced. It will be reducing by 1. M minus 3, next m minus 4, next m minus 5. Ultimately you will get m minus m. M minus m means I0. Finally you will get I0. You will get I0 here. Finally you will get I0 here. Thus notice this term, I0. If you get I0, then for m we have put here m equal to 3. Then m equal to 3 you will have to put here also. 2 into 3 minus 3, 6 minus 3 means 3 divided by 3, 8. Thrice divided by 3, you will have to put here. M is equal to 3, 6 minus 1, 5, 8 divided by, 4, 5 8 divided. M is equal to 3. 5a divided by 4. Next term, m is equal to 3. 3 into 2, 6 plus 1, 7 divided by 5. 7a by 5. You will get this. I am will be whole down. This term. Suppose this number is star. Suppose this is star. Now I0, I am going to find I0. I0 is equal to integration 0 to twice a 0 to twice a x to the power 0 twice ax minus x square this root of r dx. I0 will be equal to this. This is equal to I0 will be equal to this. This is equal to 0 to twice a x to the power half twice a minus x whole to the power half dx. You will get this. Put x is equal to twice a sine square theta. This means dx equal to 4a sin theta cos theta d theta for a sin theta cos theta d theta x equal to 0. This means theta is equal to 0. X is equal to twice a. This means theta is equal to pi by 2. Theta is equal to pi by 2. Therefore I0 equal to. Therefore I0 equal to. Therefore I0 equal to. Integration theta is equal to 0 to pi by 2. X to the power half. Twice a sin square theta whole to the power half. Twice a minus twice a sin square theta whole to the power half. 4a sin theta cos theta d theta. 4a sin theta cos theta d theta. This is equal to, you will get twice a whole to the power half, again twice a whole to the power, twice a whole to the power, from this term you will get this, into 4a, 0 to pi by 2. It will be sin theta, it will be cos theta, it will be again sin theta, and it will be cos theta d theta. Perhaps you have written this. This is equal to, this will be twice a into 4a, 8a square, integration 0 to pi by 2. Sin square theta, cos square theta d theta. The same formula will have to be applied here. 2 minus 1 divided by 2 plus 2, integral 0 to pi by 2, sin square theta d theta. This is equal to 8a square, 1 by 4, 1 by 2 into pi by 2, 4, 2, 8 cancelled, pi a square by 2. This is equal to pi a square divided by 2. No, not it. Pi a square divided by 2. This means I0 is equal to pi a square divided by 2. We have got I0 equal to pi a square divided by 2. Thus I0 is equal to pi a square divided by 2. Thus I0 equal to pi a square divided by 2. Therefore from star you will get. Therefore star implies, this implies, I am equal to, you see here, I am equal to twice m plus 1 divided by m plus 2 into a. First one is this, twice m minus 1 divided by m plus 1 into a. Number 2, twice m minus 3 divided by m into a. Dot dot dot. In this way, pi square by 2. In this way, 7a by 5 into 5a by 4 into thrice a by 3 into pi square divided by 2. A square by 2 into pi. You may write like this. Now I will simplify this one. I will simplify this. Notice that, first you see the denominator here. See the denominator. 2, 3, 4, 5, 6, 7, up to m plus 1, m plus 2. What does it mean? 1 into, 2 into, 3 into, 4 into, 5 into, up to m plus 2. It will be factorial m plus 2 in the denominator. This means in the denominator you will get factorial m plus 2. Factorial m plus 2, you will get factorial m plus 2. Again, you see. From 3, you see how many a's are there. I am going to write this. It is 3, 4, 5. From 3 to m plus 2, how many terms are there? From 3 to m plus 2. If it is from 1 to m plus 2, the number 1, 2, 3, 4 up to m plus 2. Number of terms is what? M plus 2. If it starts from 3, 3, 4, 5, 6 up to m plus 2, then number of terms will be m plus 2 minus 2. This will be equal to m. A to the power m plus 2 minus 2, you will get m plus 2 minus 2. What? From this term, from this up to this. Another 2 is there, another 2 is there, into a square. I am writing here separately, into a square. Pi also can be written here. Only we have to write the terms in the numerator. It will be twice m plus 1, twice m minus 1, twice m minus 3, 7, 5, 3. Just write it in reverse order. If you write it in reverse order, then you will get 3, 5, 3. No. 1, 2, 3, 4. Yes, this 2 has already been taken. To write this one, this 2 has been taken. 3 into 5 into 7 into dot 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 up to twice m minus 3 into twice m minus 1 into twice m plus 1. Am I right? Am I right? We have written the denominator first. 2, 3, 4 up to m plus 2. It is factorial m plus 2. Thus we have written this. A. Counting from this, you see 3. In the denominator, for every A, there is a denominator. The first is 3, then 4, 5, 6, up to m plus 2. How many A's are there? M plus 2 minus 2. If it starts from 1, 2, 3, 4 up to m plus 2, then number of terms will be m plus 2. But it starts from 3, therefore the number of terms will be m minus 2. M plus 2 minus 2. M plus 2 minus 2. And then A has been written, this square also has been written, pi has been written, and the terms in the numerator has been written in the reverse order. 3, 5, 7, like this. Clear? Now, I am equal. This means I am equal to. This is equal to. This 2 will be cancelled. A to the power m plus 2. A to the power m plus 2 divided by m plus 2 factorial into a square pi. Oh, no, not a square pi. This a square has been written into pi. For this, I am writing here 1, 2, 3, 4, 5, 6, dot dot dot, twice m minus 3, next twice m minus 2, next twice m minus 1, next twice m, next twice m plus 1, and in the I should write it in the upper side of this here, into twice m plus 1. Thus I am writing here. And in the denominator, what terms in the numerator has been added? What terms have been added in the numerator? You see, 2, 4, 6, twice m like this. 2, this has been added. This has been B6 dot dot dot, twice m minus 2, twice m. Before this term, twice m minus 4, This term has been added. Multiplying numerator and denominator by. What does it mean? Multiplying numerator and denominator by. Numerator and denominator by 2 into 4 into 6 into dot 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 twice m minus 2 into twice m. What we have done? We have done this. Multiplying numerator and denominator. This means I am equal to a to the power m plus 2 divided by m plus 2 factorial into pi. You see, 1, 2, 3, 4, twice m minus 3, twice m minus 2, twice m minus 1, twice m plus 1, twice m plus 1. This means it will be twice m plus 1 factorial, starting from 1 up to this. And this will be equal to 2 into 1, 2 into 2, 2 into 3, like that. 2 into m minus 1, 2 into m. This can be written like this. Clear? This means I am equal to a to the power m plus 2 into pi twice m plus 1 factorial divided by m plus 2. This is factorial. You see, in every term 2 is multiplied. In every term 2 is multiplied. In every term, how many 2's are there? You see, starting from 2 into 1, 2 into 2, up to 2 into m. There are n 2's. Therefore, it will be 2 to the power m 2's, 2 to the power m. 2 to the power m. And in the bracket you will get 1 into 2 into 3 into up to m. You may write 1 into 2 into 3 dot 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 up to m. You may write like this. This means I am equal to a to the power m plus 2 pi twice m plus 1 factorial divided by m plus 2 factorial 2 to the power m into factorial m. I am writing again here because of the camera. This means I am equal to a to the power m plus 2 pi twice m plus 1 the factorial of this divided by m plus 2 factorial into 2 to the power m into factorial m. This means by cross multiplication 2 to the power m into factorial m into m plus 2 factorial into I am, this is equal to a to the power m plus 2 into pi into, you know, twice m plus 1 factorial twice m plus 1. Proved. Hence it has been proved. The second part has been proved. Dear students, the second part has been proved. Perhaps you have understood everything. Second part has been proved. I have proved this part also. Now, the third part, hence or otherwise, I shall try to solve this in both the ways. Just note down. Perhaps you have noted down. I am equal to this. I am equal to this. I am equal to this. Suppose this is number and initially we have suppose this is number b. Suppose this is number b. Now third part. integration 0 to twice a x cube root over twice ax minus x square. Twice ax minus x square dx. This part, the third part is. Compare this with the first part. In place of m, you know, compare this with the second part. In place of m, it is 3. This is equal to I3. I3 by I3. This is equal to I3. Because I am equal to integration 0 to twice a x to the power m root over twice ax minus x square dx. Therefore, this will be equal to, in place of m, it is 3. I3. I3. Thus apply b a to the power 3 plus 2 pi 2 into 3 plus 1 factorial 3 plus 2 to the power 3 into factorial 3. This is equal to a to the power 5 pi factorial 7 divided by factorial 5. It is 8. It is, factorial 3 means 6. Right? Factorial 3 means 6. This is equal to a to the power 5 pi 7 into 6 into factorial 5, and here you may write factorial 5 8 into 6. Right? Now the factorial 5 will be cancelled, 6 will be cancelled, and the answer will be, this is equal to 7 by 8 pi a to the power 5. 7 by 8 pi a to the power 5. This is the answer. Now, applying this, hence, we have proved that we have found that the third part, the answer of the third part is equal to 7 by 8 pi a to the power 5. 7 by 8 pi a to the power 5. This is the answer. Now, alternatively, hence or otherwise, alternatively, integration 0 to twice x cube root over twice ax minus x square dx minus x square dx. What will be this? This is equal to integration 0 to twice a x cube x to the power half into root over twice a minus x dx. You may write like this. Note it down. 7 by 8 pi to the power 5. This is equal to 0 to twice a x to the power 7 by 2 twice a minus x under root dx. Suppose this is I. Now put x is equal to twice a sin square theta. Very simple. This means dx equal to 4a sin theta cos theta d theta. X equal to 0 implies theta equal to 0. X is equal to twice a implies theta is equal to pi by 2. Theta is equal to pi by 2. X is equal to 0 means theta is equal to 0. Therefore, I equal to, suppose this is C. C implies I equal to integration 0 to pi by 2 x to the power 7 twice sine square theta whole to the power 7 by 2 into root over twice a minus twice a sine square theta into 4a sin theta cos theta d theta. 4a sin theta cos theta. Now this is equal to theta is equal to 0 to pi by 2 twice a whole to the power 7 by 2 plus 1 by 2. From this term twice a 7 by 2 plus 1 by 2 sin square theta whole to the power 7 by 2 means sin to the power 7 theta into it is cos theta into 4a sin theta cos theta. Alternatively, we have got this one. This is equal to twice a whole to the power 8 by 2 means 4 whole to the power 4 into 4a integration 0 to pi by 2 sin to the power 8 theta cos square theta d theta. You get this. This is equal to 64a to the power 5 integration this is equal to 2 minus 1 divided by 8 plus 2 0 to pi by 2 sin to the power 8 theta d theta. The 0 to pi by 2 sin to the power 8 theta d theta. You may write like this because since I am equal to 0 to pi by 2 sin to the power mx cos to the power nx dx. This is equal to n minus 1 divided by m plus n. I am n minus 2. N minus 2 will be equal to cos theta whole to the power 0 will be equal to 0. This is equal to 64 a to the power 5 1 by 10. It will be 7 by 8 5 by 6 3 by 4 1 by 2 pi by 2. 8 8 4 2 this cancelled. Also 3 here 2 cancelled. 5 2. Finally you will get 7 divided by 2 into 2 into 2. 7 by 8 pi a to the power 5. Right? 7 by 8 pi a to the power 5. The same result will be obtained in this way. One way. Dear students, after doing one problem, I will stop here, and perhaps it will be the last problem of reduction formula. Let me write the question. Evaluate. Integration 0 to 1 x to the power m log x whole to the power n. Evaluate this. Where m is greater than 0. It may be also equal to 1 also. Greater than or is equal to 0. And n is a integer. An integer greater than 0. N is an integer greater than 0. See, let I am n. I am n, right? 0 to 1, x to the power m log x whole to the power n. Let I am n equal to this. You see, what you will do? Integrate this by parts. Now, generally, you should it is algebraic function. I means inverse trigonometric function, logarithmic function, algebraic function, trigonometric function, and exponential function. Logarithmic function and inverse trigonometric functions are generally taken as the first function, and there is an algebraic function. This function will be taken as the second function. M will be x to the power m will be taken as the second function. Now, this is equal to log x whole to the power n x to the power m plus 1 divided by m plus 1, 0 to 1, minus integration 0 to 1 n log x whole to the power n minus 1 into 1 by x to the power m plus 1 by m plus 1 by x. Integrating by parts, taking x to the power m as the second function. Integrating by parts, taking x to the power m as the second function. You may write integrating by parts. Taking x to the power m as the second function. Integrating by parts, taking this is equal to 1 by m plus 1, 1 to the power m plus 1, log 1 whole to the power m, minus limit as x tends to 0. Log x whole to the power n x to the power m plus 1, this one. From this you will get this. Minus n by m plus 1. Integral 0 to 1. This x will be cancelled. X to the power m log x whole to the power n minus 1. Right? If you put 1, then put x is equal to 1, this one, you look at this. And if you put x is equal to 0, log 0 to the power n, this 0 to the power this. That's why I am writing here limit of x tends to 0 this. It is I am n. Suppose this is number 1. Put it as number 1. Put it as number 1. I am n. Left side is equal to I am n. Now, log 1 equal to 0. Therefore, this is equal to 0. And limit x tends to 0, log x whole to the power n minus 1, it is not n minus 1, log x whole to the power n, x to the power n plus 1, equal to limit as x tends to 0, log x whole to the power n x to the power minus m plus 1. This is from infinity by infinity. L'Hospital's rule apply, L'Hospital's rule. Then you will get m log x whole to the power n minus 1 into 1 by x. You will get minus m plus 1 x to the power minus, you will get this. You will get this. This is equal to minus n by m plus 1. Limit x tends to 0. You will get here x to the power minus m plus 1 log x whole to the power n minus 1. Limit of this, you have seen, perhaps you have seen that you have in the denominator you have found no change here, x to the power minus m plus 1, x to the power minus m. Only it is log x whole to the power n. In place of log x whole to the power n, you have got log x whole to the power n minus 1. Log x whole to the power n minus 1. Proceeding in this way, we shall ultimately get. Proceeding in this way, applying this repeatedly, we get what we will get? Limit as x tends to 0. Log x whole to the power n divided by x to the power minus n plus 1 will be equal to this some number. You will get some number into log x whole to the power 0 divided by x to the power minus n plus 1. No change of this number. This is equal to, you will get some number into limit. You should write the limit, some number into limit as x tends to 0, log x whole to the power 0 divided by x to the power minus n plus 1. This is equal to some number into limit as x tends to 0, x to the power n plus 1. It is 1, x to the power n plus 1, this is equal to 0. Therefore, from 1 we get, I am equal to 1 by m plus 1. It is already 0 minus 0. Minus m divided by m plus 1. Integration 0 to 1. X to the power m. Log x whole to the power n minus 1 dx. You will get this. From 1 you will get this. This means IMM will be equal to minus m by m plus 1. It must be equal to I am n minus 1. Right? I am n minus 1. I am n minus 1. Suppose this is number 2. This is number 2. Now replacing m is common here. M plus 1. There is no sense of m plus 1. Yeah. Replacing n by n minus 2 into, replacing n by n minus 1 into we get, replacing n by n minus 1 into we get. I am n minus 1 equal to minus n minus 1 by m plus 1. I am n minus 2. Suppose this is number 3. Applying 3 into we get applying 3 into we get I am n equal to minus n divided by m plus 1 minus n minus 1 divided by m plus 1. I am n minus 2. I am n minus 2. Suppose this is number 4. Replacing n by n minus 2 into we get I am n minus 2 equal to minus n minus 2 by m plus 1. I am n minus 3. Put here n is equal to n minus 2, n minus 3. Now, suppose this is number 5. Applying 5 in 4 we get. 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 I am n equal to minus n by m plus 1 minus n minus 1 by m plus 1 minus n minus 2 by m plus 1. I am n minus 3. N is an integer. N is an integer greater than 0. Proceeding in this way, we shall ultimately get. 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 What we will get? You see, I am n. This is equal to minus n by n plus 1. Minus n minus 1 by m plus 1. Minus n minus 2 by m plus 1. Finally, what you will get? I am. No change of this. What is I am n? It was integral 0 to 1 x to the power m log x whole to the power m. N may be 0 also. Finally, you will get I am 0. Finally, you will get I am 0. If you get I am 0, means n is equal to 3. We have put here n is equal to 3. Put n is equal to 3 in this term also. You will get minus 3 minus 1. 1 by m plus 1. Then n is equal to 3 minus 2 by m plus 1. Then n is equal to 3 minus 3 by m plus 1. This dot 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 dot. Starting from this, you will get this. Now, you see, from 1, 2, 3, 4, n minus 2, n minus 1, n. 1, 2, 3, 4 up to n. If you multiply this, you will get factorial n. How many minus 1 is there? This is equal to minus 1 whole to the power n. Minus 1. In every term, there is minus 1. Minus 1 whole to the power n. 1, 2, 3, 4 up to n. You get factorial n divided by m plus 1. How many m plus 1 are there? 1, 2, 3, 4 up to n. Up to n. I am 0. I am n equal to this. Star. I am n equal to this. Perhaps you understand this. Minus 1, minus 2, minus 3 up to minus n. How many minus 1 is there? n. It will be minus 1 to the power n. And 1, 2, 3, 4 up to n, factorial n. M plus 1. There are m plus 1 in the denominator. Multiply m times of m plus 1. You will get m plus 1 to the power n. Ultimately. Now I am 0. I am 0. Equal to integration 0 to 1. X to the power m log x whole to the power 0 dx. Log x whole to the power m. For n we have put 0. This is equal to integration 0 to 1. X to the power m, it is 1 dx. Equal to x to the power m plus 1 by m plus 1. 0 to 1. This is equal to 1 by m plus 1. 1 by m plus 1. Therefore, from star 1 by m plus 1. Therefore, star implies from star you will get I am n equal to minus 1 whole to the power m factorial n. Therefore, m divided by m plus 1 whole to the power. It is equal to 1 by m plus 1. This is equal to minus 1 whole to the power n factorial n m plus 1 whole to the power m plus 1. This should be the answer. Answer is minus 1 whole to the power n factorial n divided by m plus 1 whole to the power m plus 1. Dear students, thanks for attending the class. Thank you very much. We'll meet again in the next class. Thank you. Thank you.